Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, July 30, 2021. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you this evening from Bucks Harbor Yacht Club in Maine. These Earth and Space Reports are intended for people like you who are curious about our home planet, who care about its life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. This month, we are fortunate to have Andrew Shaner, a senior education specialist with the Lunar and Planetary Institute. I'm just going to bring up his information for the last bit. Since joining LPI in July 2009, he has been involved in multiple education projects, including professional development experiences for early career scientists, teachers, public librarians, and camp professionals. He is currently principal investigator for the Planetary Resources and Content Heroes project funded by NASA's Science Activation Program. And then his bio goes on and on after that. Today, however, Andy will talk on today's solar system. It ain't what it used to be. So Andy, please feel free to take it away.
All right, great. Thank you, Bill. I'm going to share my screen here so I can bring up my PowerPoint. Okay, there we go. I assume you're all seeing that blue and white slide now. Great. Okay, well, thank you for having me on. I'll be really honest, I don't give too many presentations, at least public presentations like this. So I apologize right off the bat, but here we go. So what I'm going to do is give you a little quick introduction of myself, and then I'll talk about what the LPI is, because I'm sure most of you probably have never heard of us. If you have, awesome. But I'll give you a quick history of where we come from and what we are, what we do today. Then I'm going to get into the solar system exploration. What is some stuff that's going on now or has been in the past few months or will be happening in the future to give you a sense of where we are in a state of exploring the solar system. I certainly can't talk about everything, but kind of some of the bigger things that are happening to hopefully give you an idea that the solar system is quite different, at least in the way we understand it, than it was even 20 years ago when I was an undergrad. Just real exciting stuff happening. So we'll chat a little bit about that. Then I'll tell you a little bit more about me, where I come from, how I got here, and then a few things at the end to talk more about how you can get involved, ways you can participate in our exploration of the solar system. So as Bill said, I'm with the Lunar and Planetary Institute, which is it's a NASA institute, so it's something that is known in NASA circles or in government circles as a cooperative agreement. So the University Space Research Association, or USRA, is technically who I work for, and this USRA has an agreement with NASA to manage their LPI, their Lunar and Planetary Institute. This is a sign out in front of our building. This was about 4 years ago in December. We don't get snow like this ever or very often in Houston. So when we do, we like to document it thoroughly. It's just it's a nice, pretty picture. When I'm not working, I am helping my wife entertain our two kids, Hudson and Stella, which pretty much then takes up the rest of my time. When I do have time, which is usually like a nap time for the kids on the weekend, I like to do genealogical research. And personally anyway, one of the cool things I discovered about 8 years ago is there's a tiny village that sits right on the border of Allentown and Bethlehem, Pennsylvania. It's called Shanersville, this is the original spelling of our last name. And it's named after the half-brother of my 4 times great-grandfather. So same father, different mother. I've been there, got to visit. There's not much to it, but it was pretty cool, a pretty cool thing to see. Okay, so about the LPI. As I said, we're here in Houston. The LPI was founded back in 1968, originally as the Lunar Science Institute. Um, the whole idea was that there was a recognition that these samples being brought back by the Apollo astronauts had great scientific value to them. And so while you had the engineers over at Johnson Space Center, although at that time it was called the Manned Spacecraft Center, um, putting this, getting ready to send the astronauts and talk to them while they were up there, there was going to be another component where we'd have the scientists from all around the world could come together to research the rocks and then uh, write the papers on them. So that was the point of the LSI, was to be um, this focal point for that research once the samples started coming back. So LBJ was at the Manned Spacecraft Center in March to announce the creation of this institute. Um, it was a big hullabaloo, and we still exist 50 years later, over 50 years later. In the early days, so like I mentioned, scientists were coming together to discuss lunar science. There was a real great shift from seeing the moon as this astronomical object, as viewed through telescopes, to a geologic object. A whole world on its own, with geology, very diverse geology, and a history and an evolution. So there were lots of meetings that took place. The very first was called the Apollo Lunar Science Conference, was held in January of 1970. It was held in downtown Houston. That conference still happens today. I'll say a little bit more about that in a second. But this has been going on every year since then, and of course has just grown. And that picture on the upper left, that's another meeting that was held at one point. The gentleman standing with his arms crossed on the left side of the picture, that's Harrison Schmitt, who was the only geologist to walk on the moon during Apollo 17. So it's fun to see these old pictures of these guys that you see today, just to see them as very young. The bottom in the middle there is a picture of the first intern class from the Lunar Science Institute. Back in 1977, we started taking interns over the summer. Still do that to this day. In fact, this year's class of interns will be presenting their research next week to wrap up their experience. And there on the bottom on the left is a picture of the post-mission briefing after the first flight of the space shuttle. There on the left there, that's Bob Crippen, who was the commander of that mission. So that mission briefing was held at the LPI. So today, over 50 years later, we not only study the moon, but the entire solar system. So in about the mid 70s, there was a recognition as lunar funding was dwindling, there was more funding being allocated for solar system research as a whole. So this is like the Voyager and the Pioneer days. So recognizing that, the director at the time decided to change the name to the Lunar and Planetary Institute. And today, like I said, our scientists study every object in the solar system with a solid surface. So that leaves out, of course, the gas giants, because most of our scientists are geologists or geochemists by training. So we, as one of our scientists, Dr. Paul Shank calls them, we leave the gas bags to the physicists and the atmospheric scientists to study. So we continue to host and coordinate the Lunar and Planetary Science Conference every March. It's held down here in this area. This is what was originally the Apollo Science Conference. It's now LPSC for short. This is the largest conference of its kind in the country. That's specifically devoted to planetary science. We have about 2,000 people attend. About as many abstracts are submitted each year. Of course, not that many abstracts are accepted. And other various meetings for the planetary community and other science communities. We have a meetings group that's really top notch that just knows how to put on a meeting. Doesn't matter what your subject area is. As I mentioned, we now have 2 summer intern programs. One is the original that supports undergraduate students, and another one is specifically for graduate students. And what this program does is introduces them to mission planning. So they will do, for example, they will plan astronaut traverses or a rover traverse on the moon. And this is something we've been doing for about a decade now. And an education and public engagement program, of which I am a part of. Okay, so what's going on out there in the solar system? What are we learning, and what are we What are we doing to learn those things? Excitingly, for the first time in 30 years, we are going to send spacecraft back to Venus. The last time we did that was Magellan, launched back in 1990. We're sending two in the next decade. One of them is called Da Vinci, and I'll let you read what that acronym means there. It's launching about 2029, but 2028 to 2030 timeframe is the target right now. This mission and another was just selected the past few months, so they're in the very early stages of the mission planning. This is going to be an orbiter that also has a probe. So the orbiter will spend, I think, a year or two in orbit around Venus taking data, looking specifically at the looking at the composition of the atmosphere, and also looking at some compositions of the surface, as well as the light comes back through the thick atmosphere of Venus into the spacecraft. After a couple of years, it will detach the probe, and that probe will descend through the atmosphere and really get some good composition data for the atmosphere and pressure data, that kind of stuff. And as it gets towards near the surface, it'll take very high resolution images, comparable to what you might get from like the Mars rovers, for example, as it gets very, very close to the surface. So those will be the highest resolution images we have of the surface of Venus, once we have them, of course. And so that won't all be, though, until about the 2030s, assuming everything stays on schedule. Two of our LPI scientists, Dr. Walter Kiefer and Dr. Justin Filiberto, are both co-investigators. So they'll be on the science team for this mission. So that's exciting to have them involved. So we don't really know much about Venus in general. That's one of the reasons I really like Venus, is because what we don't know about it. As of right now, this is our best assumptions for what the atmospheric constituents of Venus are chemically as individual elements. We don't have sulfuric acid on here because that's a molecule. This is simply just showing the simple elemental composition, the top 5 elements in the atmosphere of Venus. And this is the best we know in terms of Venus. Our surface, we have guesses for the surface based on the morphology, what the types of geology we see, but even that's from radar data, and that's 30-year-old radar data. That's not very high resolution, but that's going to change. The second mission to Venus that's been selected is called Veritas. By the way, Da Vinci is being run out of the NASA Goddard Space Flight Center in Greenbelt, Maryland. Veritas is going to be run out of the Jet Propulsion Lab in Pasadena, California. This is an orbiter as well, and it is going to have a higher higher resolution radar than what Magellan had. And it will be also taking measurements of the surface composition through radiation, ultraviolet and infrared radiation coming off the surface back out to the spacecraft. Both of these spacecraft are really trying to answer this very basic question: why are Earth and Venus so different? They're about the same size. They're located in approximately the same area of the solar system in terms of distance from the sun. But why are they so different? Why did they take such different evolutionary paths to where Earth is habitable today and Venus certainly is not? We have a lot of, sorry about that. They're vacuuming out in the hall. There's data supporting that Venus may have once been more Earth-like way back in the past. If that's true, what happened to change that? Also, this question of, were there plate tectonics on Venus? Some data from Magellan, we can use new techniques and new software to tease out what looks like might be plate boundaries on Venus, but we're not sure. This new radar on Veritas will really help us answer that question. This is the best data we have for the surface of Venus right now. This is actually a global map of Venus spread out. I've just put the top is the radar data from Magellan, the bottom is topography data from Magellan, and the equator is right there where those two meet. So all we can really tell are we have high and low areas from Magellan, and then we have bright and not so bright spots in the radar imagery on top. Um, from that, we can kind of tell, based on the morphology of the things that we see on the surface, we can kind of tell what the composition might be. Where, I mean, we were kind of leaning towards basaltic in nature, like the Mare on the moon, or Mars, or the ocean floor of Earth, for example. But we really just don't know. And these two missions are really going to give us really good data on that. And really, like Magellan, you could argue rewrote, the textbooks on Venus 30 years ago. These two are going to do it all over again. Coming a little closer to home with the moon. This is a great example of how, even though the Apollo missions are over, we are still analyzing and still studying those samples. So in addition to the rocks that were brought back, have been looked at for the past 50 years, just 2 years ago, they, for the first time, opened up these core samples that the astronauts took while on the surface. In the lower left, you can see an X-ray image of the same core sample. On the bottom, that's an X-ray image from 1974. And on the top, that's an X-ray image from 2 years ago. So it's the same sample, but much better view of it in X-rays, almost 50 years later. So when they first brought these samples back, these core samples, they knew they weren't going to open them for a long time, because they knew the technology would get better with time, and then they could decide when a more appropriate time would be to open these cores. So there are teams across the country that are opening these cores and doing analysis of the rocks, and the sample, the small rocks and the fine grained material in those that were buried, have been buried for millions, if not billions of years from the moon. So that'll really give us a real window into the past, into the moon's past. That picture on the left, that's Gene Cernan from Apollo 17. That's as he's preparing to take this core that we see in that X-ray image. And the image there in the top right are 3 scientists at the Johnson Space Center in the Lunar Curation Lab, looking at the cores a couple of years ago. Later in a couple of years, 2023, we're going to launch what's called the Viper rover. This is going to the South Polar region near the South Pole of the moon. That is of great interest right now, as it's a consideration for sending Artemis astronauts there in 2024. This is an illustration of what the rover will look like. One thing you may notice about the rover is the solar panels are on the side. They're not on the top. And that's because at the South Pole of the moon doesn't have a tilt, at least as much as the Earth does. It's very, very slight tilt, axial tilt. So as a consequence, at the poles, north and south, the sun is always right on the horizon. So there's no point in putting solar panels on top of the rover. You want to put them on the side where you're going to get the most sunlight. And that is when you're not in a shadowed area. So craters on the moon are, for the most part, they have these, they're raised rims around the outside, around the edges of them. So anytime the sun goes behind a rim, you're going to be in darkness. So if you think about how the moon goes around the Earth once every 30 days, a lunar night, if you will, when half of the moon's not facing the sun, that's a 15-day, it's 2 weeks where it's in darkness. There are some areas within, especially the low-lying areas within craters, that see zero sunlight and haven't for possibly billions of years, millions of years at the most, hundreds of millions of years. These are areas where we believe we have data to show that there's ice in there. We don't think it's sheets, just these sheets of meters of ice. It's more likely ice that's locked up in the regolith, it's locked up in the dirt, but there appears to be a significant amount of it, even if it's locked up that way. So one of the roles of this rover is to look for that ice in some permanently shadowed regions near the South Pole. Now, a permanently shadowed region could also be in the shadow of a huge boulder that just is in a position where it never sees sunlight. And we have the resolution to see boulders like that, which I'll show you here in a little bit. So the south pole of the moon is right on the rim of a crater called Shackleton, which is named for the South Polar explorer from here on Earth 100 years ago or so. And the image on the left, you can see right in the crosshairs, that's right there in the middle is the south pole of the moon on the rim of Shackleton crater. And here's a good example of how you can see Shackleton, the floor never sees sunlight. The rim does, over the course of a month or the lunar year, if you will. The rim will see sunlight, different parts of the rim will see sunlight, but inside the walls and on the floor, it does not see sunlight. So there is bound to be lots of ice down there locked up in the regolith of the moon. On the right, there's a picture, as an oblique image looking at a Shackleton crater. Here is a very, very zoomed in oblique image of the illuminated rim of Shackleton taken by the Lunar Reconnaissance Orbiter camera. And in this particular image, the south pole of the moon is up in this area roughly, the actual geographic, the south pole. And in this image, we zoom in a little more, and the south pole of the moon is roughly in this area. This image is a little, it's about 12 years old. So in the caption for it, it talks about how it may be off a few meters or hundreds of meters of the location, but more or less it's in this area. These boulders field you see here on the far left and even some up here in the left center on top, these, the smallest boulders that you can see here, like for example, that one are about 3 meters in diameter. So these are, coffee table sized boulders. And so at the resolution like this, we can see where there is shadows and where there may be permanently shadowed areas just behind a boulder, not necessarily on the floor of a crater. So lots of potential places for Viper and for future astronauts to explore. Moving on to Mars, we have the InSight lander that touched down there about 3 years ago with the main purpose of detecting Marsquakes or earthquakes on Mars, all to better understand what the interior of Mars is like, how it's structured. We have a very good idea of what the interior of Earth is structured like based off of our earthquakes that we measure here, and knowing the properties of physics and how waves move through solids and liquids or molten things, just understanding all that, how waves get diffracted when you encounter different mediums of different densities. We've been able to get a pretty good picture of what the Earth's core is like. InSight is helping to do that, and Mars certainly is not disappointing. I think up till recently, they've detected over 700 Mars quakes, most around 3 to 4th magnitude. But in 3 papers that came out just this week, each paper from the InSight mission, each paper is describing what our initial results are and our kind of our new understanding of what the interior of Mars is structured. So one paper was about the crust, a second paper was about the mantle, and the third paper was about the core. So in terms of the core, it's a little thinner than has been expected. And depending on whether or not there's 2 or 3 sublayers, which more analysis of data should bring out over the coming years, that crust is either 12 or 23 miles thick, so a little thinner. The mantle then extends down another 969 miles below the surface. And the core has been quite a surprise. From this data is showing us that it is a molten iron core, so not solid. So the Earth has the inner core of the Earth is solid iron. The outer core is a liquid or a molten. So we don't know if there is an iron core in the middle of that. Hoping to get more data to tease more data out to see if that's the case. But that was a surprise. It's a surprise because Mars does not have a global magnetic field. At least it doesn't today. And based on our understanding of how planetary scale magnetic fields are formed, you've got to have a liquid interior and a solid interior. You've got to at least have a solid and liquid interior sloshing around to create that electric field that will then create a magnetic field. But Mars doesn't have it. So this is a surprise to see a molten iron core, a liquid core moving around, sloshing around, so to speak, though that's not very accurate. Sloshing is not a good word to use. Another surprise is it's bigger. The core is larger than we would expect. It's over half the radius of Mars, or half the diameter of Mars. That has been a surprise as well. So more data will be coming in. They'll be taking a closer look at those data, kind of filtering out the noise out of the seismographs that are caused just by the wind blowing against the instrument. But exciting stuff from Mars, from the interior, and more to come. And this has consequences, but this has implications for better understanding the formation of Mars and its evolution. Um, there is a model right now called the Grand Tack model, which explains why the planets are where they are in the solar system, given their sizes and their characteristics, their properties. This could have implications on that model, for just as an example. So things are always changing. 20 years ago, I took an astronomy class as an undergrad. Well, I took a few, but the first one I took, I was watching this video at home with my mom, and I remember she made a comment, "We didn't know this when I was a kid." And so it's kind of funny because I would tell my kids now that if they watched the kind of shows that I watch, but uh, they don't. OSIRIS-REx was sent to asteroid Bennu 5 years ago, in September of 2016. It has completed its mission at Bennu and mapping, imaging the entire surface, mapping the surface's composition, and taking a sample and to bring it back here to Earth. So the spacecraft left Bennu on May 10th and is scheduled to come back on September 24th of 2023. As the spacecraft approaches the Earth, it will let go of a capsule containing the samples. The plan is for that capsule then to come through the atmosphere, parachute down to the Utah test range, where it will be recovered by scientists, and those samples will be brought back here to Johnson Space Center for curation. NASA actually has a deal with the Japanese Space Agency to allow Japan to have a portion of the sample that comes back. Japan has had 2 successful asteroid return missions called Hayabusa, or one, I don't remember. Anyway, they do have at least one, and they had an agreement with NASA where NASA would get some of those samples as well. So in exchange, they will get some of the OSIRIS-REx samples. So that'll be coming back in another couple of years. More exciting stuff, a sample return from asteroids. This next one, this is a GIF. This is 82 different images put together, showing the sample arm on OSIRIS-REx hitting the surface of Bennu, getting its sample and pulling right back up again. So this is what was called tag, or the touch and go maneuver, to get the sample. It was a quite ingenious way. Basically, when that sampler hit the surface, it put a burst of nitrogen gas onto the surface that then kicked up the debris, and then came up into the collector, and then pulled back, and then stowed it, and now it's on its way home. In October 16th of this year, another mission to the asteroid is launching. It's called Lucy. The Lucy mission is actually named after the skeleton, the early hominid that was discovered some time ago. Because just like that discovery has helped scientists better understand human evolution, this mission will better help planetary scientists understand the evolution of the solar system. Asteroids, as you probably know, are some of the building blocks, the remnants of solar system formation. So within them, they record the very early solar system, what things were like back at that time. So this will launch on October 16th of this year. Well, that's when the launch date opens, the window opens. So hopefully it'll go the first time. The total mission is going to be about 12 years. Of course, it's going to take a long time. It is going to visit Trojan asteroids, which share an orbit with Jupiter. So there are some Trojans that are on a leading edge, they lead Jupiter around the sun, and there are some that trail Jupiter around the sun. It's going to visit 7 asteroids. I'm not saying all 4 Beatles are represented on here. Davis Sobel, who's a really great science history and science fiction author. If you've ever read her books, you're well aware of her. Einstein has a quote on there, for example. So this is on the spacecraft, and will be out there for posterity. Okay, so that's some of the more exciting stuff or new stuff happening or has happened in the past couple of months or is happening in the next few months. There's more I could have talked about, but I didn't want to spend too much time um, on that because I did have a time limit. So I'll tell you a little bit more about me, kind of how I got here. So I was born and raised in Wichita, Kansas, which is not exactly it doesn't is not a location that comes to mind when you think astronomy or you think space science. Given that, though, I did have opportunities that I took advantage of, and other experiences that impacted me. You know, as I look back now, I realize they had an impact on me. Um, Near in the left, upper left, so there's a picture, like a little kid drew a picture of a moon with a flag. I drew that when I was in kindergarten. Um, it was part of some class thing we did. We drew pictures of all the planets and the moon and the sun. And I came across it when I was home from grad school one Christmas because moms keep everything, and she happened to pull this out and show it to me. Um, and so recently, I've been showing that from time to time since I do a lot of things with the moon right now. Garden on the Moon is a novel by Pierre Boulez, science fiction. If that name rings a bell, he wrote Bridge over the River Kwai and The Planet of the Apes, those original books. If you have a chance to read that, if you haven't, I highly recommend it. It's about the space race and has a very interesting twist at the end of it. And that's all I'm going to say. But I would really recommend you read that book. I read that when I was in high school. When I got to college, when I was an undergraduate at Wichita State University, where I did my bachelor's in secondary education, I worked at a public observatory just outside, just to the west of Wichita, leading public programs during the weekends. I also had a chance to work at the Science Center that actually didn't open until the year 2000 in Wichita. I was a planetarium presenter there. I also was part of my manager wrote a grant to NASA. It was a particular grant, education grant at the time, where we were able to purchase two telescopes, a C8 and a 4-inch Orion refractor. And we bought an H alpha filter and a white light filter, and we used those to show visitors the sun on sunny days. Um, so I got experience speaking with the public about the sun and about astronomy in general at the observatory. So there were some early influences. In the Mars opposition of 2003, we had the telescope set up at the Science Center for visitors to come see Mars and talk to them about it, and that was really fun. My manager there at the Science Center also had a profound influence on me. He's an astronomer, has but works in the planetarium field. He taught me the difference between looking through a telescope and observing through a telescope. I'll never forget that. And finally, there's a little space. Well, it's not little, really. It's a space museum. It's in a town called Hutchinson, about 40 miles northwest of Wichita. It's called the Kansas Cosmosphere. This museum, it's a space museum that is second only to the Smithsonian in its collection of U.S. space artifacts. In fact, they house the Apollo 13 command module. Is or not the command module? The command module is there, um, and second only in Russian space artifacts to some museum in Russia. So I grew up not too far from there and made lots of trips when I was young. So I graduated from Wichita State, had my licenses to teach physics and earth space science at the high school level. Um, but while I was there, I was like, I'm not sure that's what I want to do. And at the same time, I was really getting into astronomy and the science of it and astrophysics. I had taken some, uh, calc-based astrophysics courses. I was really getting into that. And so then I had an opportunity to go to graduate school at the University of Arizona in Tucson. Although I knew I didn't want to do research either, but I didn't want to be in a classroom. So anyway, I found out there was a research team there as an astronomy education research team. And so it was kind of this nice fit right in the middle of what I thought I wanted to do. So I applied, got in through the College of Education, which is there, that picture in the top left. Spent a lot of time there, of course. The picture on the left is the Kuiper Space Sciences Building. That's the home of the Planetary Science Department and the Lunar and Planetary Laboratory. Spent time there. So I did a master's in teaching and teacher education with a minor in planetary science. So what I did to get paid as a grad student was I worked in the education program for the Mars Phoenix mission. This mission launched in August of 2007, landed in May of 2008. It landed near the North Pole of Mars. There's a picture, a panoramic taken by the spacecraft there at the bottom. And this picture I have as an inset on the left is it speaks to me a lot because in January of 2007, I had a chance to go to Lockheed Martin, where the spacecraft was built, and I had a chance to put on a clean suit and get in, or the bunny suit they call it, get in the clean room. I mean, fully garbed, gloves, mask, hairnet, everything. I got to go in and stand right next to the lander and get on a ladder and take pictures of it. It was awesome. Then a year and a half later, to see it sitting on the surface of Mars, has seen from orbit there in that picture on the left, taken by the HiRISE camera that's orbiting Mars. And we knew, the mission knew, that it would only last for at most 5 or 6 months. After that time, the winter would set in the northern hemisphere of Mars, and at the poles, CO2 ice condenses down to the surface and forms ice, dry ice. And we knew that there would probably be enough that the spacecraft wouldn't survive the winter. So it turns out when the winter was over, a HiRISE imaged the landing site again, and there you can see in 2010, it's very dark. There's not a lot of reflection. It was probably destroyed by the ice just shifting over the course of the winter. So that was just that's always just had an impression on me. How I got to see it before it launched, saw the launch, saw it sitting there, and then saw it after it had kind of been basically destroyed. Just take a moment to say that about Star Trek, and that is that Star Trek did not influence me. I don't have anything against Star Trek. It was just, particularly the original series, it was just before my time. Um, there was movies that came out when I was younger, and I liked them. It's just not something that inspired me. And there are a lot of people in this field who were inspired, particularly engineers that I know, who were inspired by Star Trek. A lot of my friends that I went to grad school with love Star Trek. I'm just not one of them. But I will tell you what did. I really thought about this, and my turning point to get interested in space science really came the summer before my senior year of high school. That was 1997. The movie Contact came out that summer, and the Mars Pathfinder rover landed on Mars on the 4th of July that year. I can remember sitting at home just flipping channels on that day, and I think it was on CNN. They were showing shots of this, and I was blown away by it. And in a weird twist of fate, later that year, there was a newspaper article about results from that mission. And the gentleman who built the camera that took this image from Pathfinder, he is quoted a few times in the article. And at the time, I cut it out. I'm like, okay, it's about Mars. That's cool. I'm going to cut it out. I'm going to hang on to it. Then that same year, when I was home for Christmas, and my mom showed me that picture, I came across this article, and I'm reading through it again. And I was like, wait a minute. The guy they quoted, the guy who designed the camera for Pathfinder, Peter Smith, was my boss on the Mars mission. He was the principal investigator for the Mars Phoenix mission. His office is 20 feet down the hallway from mine. So that was one of those little twist of fate things where I was really blown away by that. So I took that article back to Tucson with me, got a picture I had of me and Peter, glued them on a piece of paper together and put them in a frame, and I've still got that frame. All right, a couple of things you all can do to get involved with our exploration of the solar system. There's lots of citizen science programs out there related to either astronomy or planetary science. This one, just an example, is called Planet Hunters Tests. You look at light curves to see if there is a possible transiting exoplanet in front in that data. This is something you can do just from your computer at home or on your tablet or your iPhone, for example. For other examples of citizen science things that you can do, NASA has a web page with a whole bunch of them that you can get involved with. It's just science.nasa.gov/citizen science. So check that out. There's also Earth Science. citizen science applications as well. And some of you may know about International Observer the Moon Night. Astronomy clubs are a big part of this. This is an annual event every year. It's held in September or October. It depends on the moon phase. This year it's October 16th. I sit on the coordinating committee for this event. Right now we are working on putting together an hour-long event that will be broadcast through NASA TV, on NASA TV and its social media channels like YouTube, Facebook, all that kind of stuff. So be looking for that on October 16th. If your club is going to participate, or if you as an individual even participate, you can go to the website there and register your event, or that you were at home and you observe the moon. It don't need telescopes, as you all know. You don't even need binoculars. It's just there. And the whole goal of this event is to just encourage people to go out and look at the moon and to learn something about lunar science and the solar system. This year, I believe, is the 12th year of this event, and I've been with it every year. So it's been interesting to watch it grow. All right, I'm going to stop. So thank you all for the opportunity, and I will certainly try to answer any questions you may have.
Well, okay. That was wonderful and sweeping. There's just so much, there is just so much to the solar system, and the objects there, they have such different personalities that you have to have so many approaches, even with the solid objects. That was interesting to me as well, that LPI focuses on the solid objects. Does that include the solid objects in orbit around Jupiter and Saturn?
Yes, it does. It does. And any moon that's large enough where we can really study its geology around any of the gas giants, we do. Paul Schenck in particular has done a lot of mapping and created a lot of maps of those moons.
Okay. Bill Wall is interested in asking a question.
Sure.
Yeah, hi. Yeah, I enjoyed your talk. I should say that I was inspired by Star Trek, despite its flaws, and not the least because two of the stars happen to be Canadians. So, are there still rocks at lunar rocks at LPI?
The LPI, no, we don't have like research, like instruments for rocks. We're mostly office space. Rocks are all housed over at Johnson Space Center in the lunar, called the Lunar Sample Laboratory. We do occasionally have rocks here, meteorites, sometimes lunar samples. If we do have some microscopes, and we are actually getting a, I think it's a scanning electron microscope. So we will have something like that we can analyze with. But for the most part, if our scientists need anything, they just go over to JSC.
Right. Well, yeah. Bill anticipated one of my questions. So another question is, Da Vinci is going to land on the surface of Venus, which is not a forgiving surface. So how long do they expect it to last?
I have not read anything about that. It's everything I have found about it doesn't say anything. So I guess as they get farther along and they have more information about it, I could ask our two scientists. They probably know. But the longest anything has survived has been a couple of hours. So unless, now I know there are different technologies and different things they've considered doing to get things to last longer, and including putting material on that can just like shed off like onion layers over time to help to keep heat off of it. I don't know if they're going to be doing that, but I would say probably no more than 2 hours.
Thanks.
Sure.
So I have an educational question. I know you're involved with a program that engages high school students, and then also you have the undergraduate and graduate programs for the internships. But what about the teachers, the teachers, middle school and high school teachers in particular? As you know, the Next Generation Science Standards places Earth and space science up with the other ones, the physical and the life sciences, and yet the amount of teaching of Earth and space sciences is way below what is being taught in those other sciences. And so there's so many teachers who are not teaching it either because their curriculum just doesn't include it or because they are not comfortable with teaching it. And so I was just wondering whether you had anything that could move the level a little bit.
For years, until about 5 years ago, LPI's education program's bread and butter was teacher professional development, particularly in earth and space science. Christine did a lot of that. My colleague, Christine Shupla. With the changes within NASA and particularly the Science Mission Directorate, which is that's who's responsible for all the missions to Mars, all the missions into the solar system, all the space telescopes, all that stuff. We were funded through them, and they 6 years ago changed their approach to how they're doing education and formal, what they would categorize as formal education activities. So things like teacher workshops. Very few people are funded to do that. There is they have really de-emphasized that within the Science Mission Directorate. The Office of STEM Engagement, which kind of covers the rest of NASA, they still do professional development for teachers. So you can learn about those. NASA has an e-newsletter they send out every Thursday morning that will have those kind of opportunities in it. But yeah, that's something we used to do, and we're honestly just not allowed to.
Well, maybe it'll change, right? I think so many things have changed in the past. Maybe it'll change back when you realize how important it is for people to understand what's going on here on Earth, and how inspiring it is to understand what's going on in space.
Absolutely, and we've tried to look other places for funding to do workshops like foundations and things like that, and it's fortunately in our position, it's just not feasible to work with them.
Sure. Well, this was a far-ranging. There's just so many beautiful objects. I wonder if we polled our audience, what object would you be most excited to explore? I'm sure we would get a diversity of opinions.
Oh yeah, I'll bet everybody has their favorite and all kinds of different reasons. I'd say mine is Venus. I love though the color of Neptune.
Yes, it's a little bluer than Uranus, and they don't know why, right?
Well, so my understanding is that, so those are old pictures from Voyager, right? And my understanding is that it appears that blue because of a filter. In reality, it's about as bluish green as Uranus.
They look really different in a telescope.
Do they?
Identifiably different. Yeah, you can tell the difference between them by the color.
Well, that's good. Filter or no, I love that picture of Neptune though. I really like that color.
It's the background for our club logo.
Is it? Okay.
Yes, it is. Hey, while I've got your attention, I did have a question, if that's all right, Bill.
Please.
You were mentioning inescapably, I think, that Venus may have a cautionary tale to tell about global warming. And I was wondering if you had heard any rumblings about more panicked proposals to find out where in the hell Mars's magnetic field went and its atmosphere with it, unexplained.
Right. So the atmosphere question. So the big question with that was, okay, so it lost the magnetic field, which as you know, was very important to maintain an atmosphere.
Right.
The question of where the atmosphere then went has been at least partially answered. The MAVEN mission that launched back in 2014, I believe. Maybe that was, yeah, anyway, when it launched, it was sent specifically as an orbiter to answer that question. And what we found, it's a little bit of both. Some of the water went into the surface and the subsurface, as we see that as ice on the surface. We also have data showing it under the surface, which is actually one of the goals of the Phoenix mission, was to go up there and dig into the ground and uncover ice in the subsurface, which it did. And some of it escaped through space.
Right.
So it's a little bit of both. So now the question
really
is,
my question. My question was, if the root cause of that phenomenon is the disappearance of the magnetic field, I would think it would generate some tension around here.
well, it generates a lot of interest because it's an interesting problem, right? And so InSight's starting to give us some insight into that, if you will, because if it has this molten core, it's not solid like we thought it was, which would mean it had cooled off long ago, which would explain why it has a magnetic field. So why does it not have a magnetic field if it at least has a molten core?
Mhm. Yeah.
We're still learning.
Yeah.
So this could happen here next month, and we wouldn't be surprised.
Oh,
What's that?
The loss of the magnetic
Oh.
field.
We wouldn't know. Of course, our deal with magnetic field now is what happens when it flips.
For the umpteenth time.
Yes, again.
And it's flipped a number of times, and life is still on Earth, so it can't be that bad.
Right.
that's a good point.
I just like that it's there, you know?
It's kind of reassuring. It is.
It's
like
all that cosmic radiation can't be the best for you. So I am being told that I'm being told that I should be getting out of the yacht club. Their little party is ending, so I'm going to
oh goodness.
thank you all for coming, and thank you, Andy, in particular, for this wonderful, far-reaching talk. And I'd also like to ask all of you to consider new people to give presentations. This happens monthly, and I'm hoping to keep it up, but it requires new people willing and able to give interesting presentations in the Earth and space sciences. So on that, I'm going to thank Andy one more time and bid you all adieu. Take care.
Well, thank you all so much.
Nice
Thank
talk,
you.
Andrew. Bye-bye.
Thank you.